Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. What is the major product of this reaction? So this is actually student hydroboration reaction. Before going to the details, I request everyone, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. Don't worry, after some time you'll have the right answer with explanation. I believe we have tried, so let's start. So here this is a diene, cyclooctadiene, and reaction with B2H6. What is the product? Before going to the answer, let's learn a little bit about this B2H6. By the way, this B2H6 is actually a dimer molecule. Dimer of 2BH3. Why? If you look at this 2BH3, this boron is attached with 3 hydrogens. Resulting means 3 6 single bonds. So each single bond has 2 electrons. So total this boron outside there are 6 electrons. So in order to reduce this electron deficiency or incomplete octet nature, they undergo dimerization resulting B2H6 formation. Now previously we have seen that 0.2 equivalent of B2H6 is taken. So if you take this is 0.25, then I can say it is overall 0.5 equivalent. Why? Because 2BH3 produce. Point number one. And second, how BH3 get added across a double bond? Actually, more specifically, if I say pi bond, so it is actually syn addition. By the way, remember the product is saturated. That's why it is syn, not cis. Do not get confused. Okay. So this addition takes place, syn addition, both same side, and later on, if you look at reaction doesn't stop at here. Why? Because BH bond got attached across this alkene. Still 2 hydrogen remaining here, so that 2BH can also undergo addition with 2 other alkene molecule, so resulting these result called trialkyl boron. So this part I think you all are familiar. Now here little interesting for this problem. Now, so we understood that we have prepared 0.5 equivalent of BH3. So this is 1 equivalent, this is 0.5 equivalent. Okay. Now, next what happens? So these BH undergo addition reaction with any one of the alkene. Fine. So syn addition, it produces this is BH2H. Now remember here what will happen? So another BH3 will react, or these BH2 means this one BH bond will get attached to this carbon-carbon pi bond. So remember one very important statement, that is intramolecular reactions are always preferred over the intermolecular. So this is intramolecular reaction. It is preferred over inter. Okay, so that's why these one of the BH will get attached there. Now question, where the attachment will take place? Now let's start the counting about this. Now here ring formation takes place, so stability of ring is also an important factor. Now let's start here. 1 2 3 4 5 6. So this side if I go 6 member, and what about the other side, because we need to think both of the sides. So this is 1 2 3 4 5 6. So you can see that if this boron got attached here, both sides 6 member ring, and we know 6 member rings are stable. But if you think, sir, let's 2 and 5, if you attach this part, what will be the consequence? In this way the product will be one case 7 member, another case 5 member. Some amount of ring strain is there. So in order to avoid that, thus both sides 6 member ring will be followed. So you may think in this way, 1 2 3 4 5 6. Other side is also the same. I suggest you to draw this by yourself. By the way, this molecule has a name, 9-BBN or 9-bora bicyclo. It's a very big name, you can check. So still there is one hydrogen remaining extra. Okay, so this is the uniqueness of this reagent. So what is the answer of this question? Answer is option C. I think you have understood. Now if this question appear in your exam less than 30 seconds, how can you solve? First you understand that 0.25 equivalent means 0.5 equivalent of BH3. 0.5, so here 1/2, so there is a high chance intramolecular reaction. So you may think, sir, this is gone, because for one molecule there are 2 boron center. This is not possible. Now you may think, sir, intramolecular versus intermolecular means this one is inter and the other is intra. Student, do not get confused. Inter. So intramolecular reactions are always preferred over intermolecular. This is the answer. Now this is obviously no reaction. No reaction will not happen. Now, so what is the answer? Obviously this. It is very easy if you think logically. Okay, so this is the answer of today's question. Now let's learn a little bit about the reagent, this importance of this 9bbn. If you look at, this is the 9bbn, but still you can say, sir, this boron attached to one carbon means 2 electron, another carbon 2 electron, hydrogen 2 electrons, so this boron still is 6 electron. So in order to reduce that electron deficiency, these 9bbn undergo dimerization, like B2H6 we have observed. Similarly here also 9bbn undergo dimerization. B2H6 is a dimer of 2BH3. Similarly these two molecules of 9bbn undergo dimerization to produce this. By the way, this part is called the banana bond or 3C 2 electron bond, many things. Now this is very interesting. Why? Because this is a first of all bulky boron. Why? Because you can see that this side a very bulky group attached, bulky group. So this bulky boron is very useful for selective. Now bulkness means is always prefer to add at the less hindered situation. Side, this boron will go, obviously hydrogen will go the other position, and it is a monohydroboration reaction reagent. Now if I say BH3 or B2H6, trihydroboration possible. So there is a chance of over reduction, but in this case monohydroboration, for that means it is a very selective reagent, so it is utilized in organic chemistry widely. So this is the overall discussion. I believe this video may be useful. Thanks for watching. If you really enjoy the content of my channel, please help this channel to grow, and please do not get confused about the logo of my channel. I request you to read this part, and remember, I never support any brutality. So see you in my next video. Bye bye.